Hi, in this lesson we look at how to factor trinomials of the form x squared plus bx plus c. So before we can do that, let's develop a rule for factoring x squared times bx plus c by examining the product of x plus r times x plus s. So if we go ahead and we expand this using FOIL, we get that this expands to x squared plus rx plus sx plus rs. Now, we can factor x out of these two middle terms, and you'll see why I'm doing this in a second. So we get x squared plus r plus s times x plus rs. Now, why did I just do that? And here, if I distribute x into r plus s, I would just get these two middle terms back using the distributive property. So the reason why I wrote this expanded polynomial in this form was because now it's starting to look a lot like x squared plus bx plus c. So if I think about r plus s, or if I were to rewrite r plus s as b and r times s as c, well, if I have two numbers or a trinomial of the form x squared plus bx plus c, where I can find two numbers that add to b and multiply to c, I know that I can rewrite that trinomial in the factored form x plus r times x plus s, because that'll just expand to x squared plus bx plus x squared plus bx plus c. So let's put our rule to good use. So the rule is that when we have a trinomial in this form, we find two numbers that multiply to c and add to b. So let's go ahead and we'll put that rule to good use. So in the first question, we're asked to factor completely, and we're given a trinomial 4x squared plus 36x plus 56. Now this trinomial does not look like the one that we have above because it's got a coefficient of 4 beside x squared instead of a coefficient of 1. But if you look at the other two terms, 36x and 56, they're both divisible by 4. So that means that we have a common factor here. And we can common factor 4 out of this trinomial to get 4 times x squared plus 9x plus 14. And I got this because 36x divided by 4 is just 9x, 56 divided by 4 is 14. So now the trinomial inside these brackets does have a common, or it does have a coefficient of 1 beside x squared. So now I can find two numbers that multiply to 14 and add to 9. And those two numbers are 7 and 2. So this factors to, this factors to 4 times x plus 7 times x plus 2. In the next part of this question, I'm asked to factor p squared minus 4pq minus 21q squared. So this might not look like the similar, or it might not look that similar to the trinomial that we have above, because we have a factor of q here and two factors of q here. But let's see if we can still follow our rule. Well, the rule is that we find two numbers that multiply to this term and add to the coefficient on this term. So let's treat 4q as though it's our coefficient, okay? So if we, or negative 4q as though it's our coefficient. So the game here is to try to find two numbers that multiply to negative 21q squared and add to negative 4q. And let's see if we can do that. Well, two numbers that multiply to negative 21q squared would be negative 7q and positive 3q. And does that add to negative 4q? Well, if I add negative 7q plus 3q, I do in fact get negative 4q. So this factors to p minus 7q times p plus 3q. In the last example, I have x to the power of 4 minus 3x squared minus 40. So again, I have this a quartic term here, and then the middle term is a quadratic. So that does look a little bit different than the form of the trinomial that I had above. But I can think about this as I can rewrite this as x squared because x to the power of 4 I can rewrite as x squared because when I raise a power to a power, I multiply the exponents. Minus 3x squared minus 40. So now I can make a substitution. I can say let x squared be equal to a, and I'm just going to replace x squared with a. So this is going to be equal to a squared, where I've just replaced x squared with a, minus 3a minus 40. So now this is a type, or this is a trinomial with coefficient of 1 beside the quadratic term. So I can factor this by saying what two numbers multiply to negative 40 and add to negative 3. So two numbers that multiply to negative 40 and add to negative 3 would be negative 8 and positive 5. So this factors to a minus 8 times a plus 5. Now, my original expression wasn't in terms of a, and I want my factored expression in terms of a. So I'm going to rewrite this as I'm going to substitute x squared back in for a, and I get x squared minus 8 times x squared plus 5. Now, all of these intermediate steps are not really necessary. It's just for you to understand how to factor this, because if I just look at this, I can kind of see that this is a trinomial that's similar to the form above, and I can kind of fill the degree in just by using guess and check, which is a lot faster. But this is just to sort of help you understand why I can factor this in the same way as I did above, using the rules that we developed. So that concludes this video, and we'll see you in the next lesson.